So, a rock just crashed into the moon at 78,000 mph, creating an explosion equivalent to 100 lb of TNT, and the whole thing was caught live. Then, a week later, it happened again, and the second impact was even brighter. But the timing of these hits is raising some serious questions because they're coming from one of the strangest objects in our entire solar system. So, on December 12th, a bright flash appeared on the dark side of the moon. The whole thing lasted less than a second, but the explosion was bright enough to be detected from Earth at 240,000 miles away. Now, the rock that caused this explosion was only about 1 to 3 inches wide, about the size of a golf ball. So, how does something that small create an explosion visible from Earth? Well, the answer is speed. This rock was traveling at 35 km or 78,000 mph. At that speed, even a tiny object carries massive amounts of energy, and when it slams into the lunar surface, all of that energy converts instantly into heat and light. Now, on Earth, our atmosphere acts like a giant brake. When a meteoroid hits our atmosphere at high speed, the air resistance slows it down and burns it up. Most rocks never even reach the ground. The ones that do survive have lost 99.99% of their energy. But the moon has essentially no atmosphere, just a trace amount of gas so thin it might as well be a vacuum. So nothing slows these rocks down, they hit at full cosmic speed. NASA research shows that impacts like this release energy equivalent to 50 to 100 pounds of TNT. The collision vaporizes both the meteoroid and the surface material, creating a superheated cloud that glows hotter than molten iron. The impact excavates a crater several meters wide and throws up tons of lunar dust. The flash reaches temperatures between 2,000 and 5,000 degrees. Now, here's where everything gets really interesting. The timing of this impact was not random. This happened during the peak of something called the Geminid Meteor Shower. The Geminids run from early December to late December every year, with maximum activity around December 13th and 14th. So scientists are pretty confident this rock came from the debris stream that creates the Geminid shower. And that debris stream comes from one of the weirdest objects astronomers have ever studied. It is called 3200 Phaethon. Phaethon is an asteroid about 6 kilometers wide, but it does not behave like a normal asteroid at all. Most asteroids just orbit the Sun in the asteroid belt between Mars and Jupiter. They are cold, dead rocks that do not do much of anything. But Phaethon has an orbit that brings it closer to the Sun than any other named asteroid. At its closest approach, Phaethon gets within 0.14 astronomical units of the Sun, which is about 13 million miles. Sounds like a lot, but for space, that's a pretty close shave. When it gets that close, the surface temperature hits about 750 degrees or 1,400 degrees. And here's the really weird part. When Phaethon approaches the Sun, it develops a tail like a comet, except it is not made of ice and dust like normal comets. It is made of sodium gas. Scientists think either Phaethon broke apart catastrophically thousands of years ago, creating this massive debris trail, or it shares a common origin with other related asteroids that also fragmented from some ancient collision. Now you might be wondering, why would anyone care about tiny rocks hitting the moon? Well, this research is actually critical for keeping future astronauts alive. NASA is planning to return humans to the moon through the Artemis program. They want to build a permanent base near the South Pole where astronauts will live and work for extended periods. But here's the problem. The moon gets hit by these rocks constantly. NASA calculated that about 100 ping-pong ball-sized meteoroids hit the moon every single day. Each one impacts with the force of about 7 lbs of dynamite. Current spacesuits can be penetrated by particles 71 times smaller than ping-pong balls. That sounds terrifying, but modern shielding technology can protect against 99.97% of these impacts. Engineers use multiple thin layers that fragment incoming rocks into harmless dust before they reach the habitat walls. But to design these shields properly, they need to know exactly how many impacts to expect, how fast the meteoroids are traveling, and what they are made of. That is where detections like this come in. Every observation adds data to the models that will protect future astronauts. We have been monitoring the Moon for impact flashes since 1999. Since then, astronomers worldwide have recorded about 600 to 700 confirmed events total. What makes this event even more unusual is that the astronomer witnessed it live on his screen. Most detections only show up later when software processes hours of recorded footage. Actually seeing the flash happen in real time is extraordinarily rare. For comparison, the brightest lunar impact ever recorded happened in September 2013. That flash was nearly as bright as the North Star and lasted 8 seconds. The impactor weighed 400 kilos and released energy equivalent to 15 tons of TNT. Most impacts, including this one, are much smaller and last less than 1 second. But the Armagh team detected another lunar impact flash on December 19th. This one was described as among the brightest flashes recorded in recent years. 2 detections during the same Geminid Meteor Shower season strongly reinforce the connection to Phaethon's debris stream. It also shows the value of sustained monitoring during known meteor shower periods. When scientists know a debris stream is crossing the Moon's orbit, they can point telescopes and increase their chances of catching impacts. So what's next? Well, the Lunar Reconnaissance Orbiter will search for the new crater once the region gets adequate sunlight. Finding it will confirm the impact energy calculations and help scientists understand how lunar soil responds to these high-velocity collisions. This has been done successfully before after the massive 2013 impact. Astronomers compared before and after images and found an 18-meter-wide crater exactly where the flash occurred. The Armagh team is still investigating all the details of their December 12th detection and waiting for conditions that will allow imaging of the potential new crater. If you watched to the end, drop me a like and let me know your thoughts down in the comments. God bless you, and I wish you a wonderful week.